Proportions. Here we consider the analysis of proportions in the case study, Mediterranean Diet and Health. In this study, one group of people followed the diet recommended by the American Heart Association, whereas the second group followed the Mediterranean diet. One interesting comparison is between the proportion of people who were healthy throughout the study as a function of diet. It turned out that 0.79 of the people who followed the AHA diet and 0.9 of those who followed the Mediterranean diet were healthy. How is the effect size of diet best measured? We will take the perspective that we are assessing the benefit of switching from the AHA diet to the Mediterranean diet. One way to assess the benefit to compute the difference between the proportion who were not healthy on AHA diet, 0.21, with the proportion who were not healthy on the Mediterranean diet, 0.1. The difference in proportion is 0.21 minus 0.1, which is 0.11. The measure of the benefit is called the absolute risk reduction, ARR. Alternatively, one could measure the difference in terms of percentages. For our example, the proportion of non-healthy people on the Mediterranean diet, 0.1, is 53%, lower than the proportion of non-healthy people on the AHA diet, 0.21. This value is computed as the quantity 0.21 minus 0.1 divided by 0.21 multiplied by 100 is equal to 53%. This measure of the benefit is called the relative risk reduction, RRR. The general formula for RRR is RRR equals the quantity C minus T divided by C times 100, whereas C is the proportion not healthy in the control group and T is the proportion not healthy in the treatment group. A third measure commonly used measure is the odds ratio. For our example, the odds of being healthy on the Mediterranean diet are 90 to 10 or 9 to 1. The ratio of these two odds is 9 divided by 3.76, which is 2.39. Therefore, the odds of being healthy on the Mediterranean diet is 2.39 times the odds of being healthy on the AHA diet. Note that the odds ratio is the ratio of the odds and not the ratio of the probabilities. A fourth measure is the number of people who need to be treated in order to prevent one person from having the alignment of interest. In our example, being treated means changing from the AHA diet to the Mediterranean diet. The number who need to be treated can be defined as N equals 1 divided by ARR. For our example, N equals 1 divided by 0.11, which is 9. Therefore, one person who would otherwise not be healthy would be expected to stay healthy for every 9 people changing from the AHA diet to the Mediterranean diet. The obvious question is which of these measures is the best. Although each measure has its proper uses, the RRR reduction can exaggerate the importance of an effect, especially when the absolute risks are low. For example, if a drug reduced the risk of a certain disease from 1 in 1 million to 1 in 2 million, the RRR is 50%. However, since the ARR from 1 in 2 million to 1 in 1 million is small, the practical reduction in risk is minimal.